Oh, g'day, it's Presso here in the home shop, and this is episode 3 on how to build a Victorian inspired steel arched garden bridge. This structure is around about 3 metres long. It's got a height to the top of the handrail of around about 1 metre, and it's about 1 metre wide. And there are 2 episodes previous to this that you can see in the playlist, and they show a lot of the elements that we use in this design, which are inspired by the sort of engineering processes that would have been used toward the end of the 19th century. So a lot of the visual cues that you see here are derived from those sorts of things like railway bridges and railway viaducts and so on. And in this episode we're going to replicate one of these steel frames for the other side of the bridge, and then we're going to look at the process I used to weld this into a single three-dimensional structure. So settle back and enjoy a little bit of comedy amateur welding. Okay, this is where we're at. So I've got the bottom frame fully welded, I've got the diagonal bracing bolted in place, and I've clamped all of the pieces which make up the second frame to the first one. So these pieces on top here, these are the stanchions, they're just loose at the moment but clamped down to the other frame. The piece of rolled steel which makes up the main span has been clamped down, and I've checked to make sure everything is flat, level, parallel and aligned top to bottom. And that allows me to go ahead then and tack all of the stanchions to the piece of rolled steel, the arch, and fully weld that off, and then I should be able to separate the two halves and do all of this work for the second frame. So I've got to weld on these lugs, or ears I call them, the handrail supports, and get all of the bracing made. And we should then be able to unite the two pieces into a single bridge structure. So let's get going. Okay, I'm just going to make sure all these clamps are really tight now. I'll go ahead and weld off the bottom of this section here, and hopefully that'll hold everything in alignment. Okay, let's do some rubbish welds. Alright, well, that's all held together at the bottom there now. It's really only relying on 2 welds, one on this side, one on the other. Until I turn it over I can't do the rest of the welds, and I would really like to keep this attached to the other frame while I make up the diagonal bracing. Now I'll try, I'll give it a go, but it's just going to make it a bit awkward with all the structure underneath here. The good thing about the diagonal braces, it will hold these stanchions at the top. And these braces work perfectly when they're under tension. If they're under compression, if they're being squashed this way, they're just going to buckle and bow. But at least one of them should be under tension at all times, and that tends to hold the top of the bridge together, the top of the handrail end anyway. I'm going to skip ahead a bit, and you'll probably catch up with me when I've got the second frame to the same stage as the first one. Check back later. You can see here I've got all the diagonal bracing in place now, and I've just started work on fitting these gusset plates, and it's quite satisfying when you fit these in place and they line up as you'd expect them to. And I mean, plasma cutting is very difficult to hold an accurate tolerance on, even when you're using templates, but so far they've lined up pretty good. The only problem is that these edges are getting quite burned as I cut with the torch, but I've got one to go, and the edge, the actual edge here, is still okay, and that's what guides the tip of the plasma torch, so it should be alright. So I get one more of these done, and then we can fit all of the plates in the centre of the diagonal braces. Just got this one to go here, and we can start on the top of the second lot of stanchions. So they're going to be cut to length, cut to angle, fit the plates to them. Now we can separate these two frames and begin our assembly. Here's a close-up of just about the only decent weld on this job, and probably the only reason why it's turned out okay is I can run the tip of the MIG nozzle along the two adjacent faces here and keep my accuracy within a reasonable tolerance. But like I said, it's just got to stick the metal together. I'm going to paint it and I'll grind some of the worst welds so that you won't see them, and we'll just pretend that I'm a good welder. And what I need to do now is take this top frame off, flip it over, weld up the other side and cut the excess off the stanchions and weld the plates with a handrail on, and get rid of the bottom frame, put that aside. So yeah, let's do it. Just checking to see if anything's moved. It's not bad. This one's probably moved over by about 1 millimetre. But other than that, it's all held pretty good. So this one, we've just got to put aside for a minute. Okay, this one is pretty much done, so it's got to go outside. See if we can knock the camera over. Okay, so what I can do now, if I can get it the other side, I can drill through for the cross bracing and make sure it's bonded to that plate there, and I'm going to cut these off and finish the welding on this side. Happy days. Let's see if I can show you at least one good weld. I've been practicing. That might be acceptable. Hey, A-bomb style. That one's all right. The thing I'm having trouble with is I just can't see what I'm doing. I don't know whether it's this face shield or my eyes. but if I can run the tip of that torch against those two surfaces, the weld's okay. But if I go freestyle it, go vertical up, vertical down, it's just horrible. Anyway, one to go, two to go. Well, it's been a bit of a marathon, but I managed to get all the fabrication done on this frame. The other frame's outside, ready to go together. But before I do that, I need to think about how I'm going to anchor this in the ground. Now, the location where this is going is sandy soil. I'm really going to have to put in some sort of concrete footing to support this. So what I did was I bought two of these post anchors. These are hot dip galvanized, and they're designed to take 100mm posts, and this material here is only 50. Now I could put 4 of them like that, but it looks a bit daggy on the inside, and it sort of goes up into the area where the timber is going to be bolted to the span of the bridge. So what I've decided to do, partly because I'm lousy, I'm going to cut these in half and just use 1/2 of each of these, and they will be bolted, yeah, like that. But it'll only be half of it, and there'll be a purlin bolt through each of those holes there. I can get up inside the tube to tighten up the nuts on the inside. So that's going to be durable enough, being hot dip galvanized. These sections of the stirrup or the post support will be anchored in the mortar or the concrete, and they'll stop it from lifting out of the concrete. And it doesn't matter that they've been cut off, they're going to be encased in concrete anyway. So we'll get these cut in half, and then what I'm going to do is get the 2 holes drilled before I start welding all of this together. I should have known that was going to happen. Ah. There you go. Looks like I have to go old school to finish it. Once again, exactly what you need on a day like today. Alrighty, just deburr that. I'm sure you're wondering why I don't just weld it, but I want to be able to disassemble the bridge, lift it off its mountings or off its footings at a later stage, if for any reason I need to do any maintenance on it, like get underneath it or something like that. So once I concrete these footings, I can lower the bridge into them, or I can unbolt and take it off. But I'll leave them bolted on, and we'll get the bridge in the right position with these sitting in the holes, and then we'll backfill with concrete. So I'm just going to spot drill through here with a 13mm bit, and then pilot drill it. Pilot drill that. So I can get those purlin bolts up in there. I mean, when this is in the ground, it's going to be a little bit more difficult to get your hand underneath there to hold that. But, you know, if necessary, it can be done. I'm wondering if I should just... No, I can't. I mean, I could, no, I couldn't do that either. Yeah, right, that's interesting. What I should have done is tap that, but there's not a lot of metal. It's only 2mm, that square tube. Yeah, I don't know, maybe. Yeah, at a pinch, you'd be able to get a finger up in there. Ooh, sounds rude. Well, I've got this sitting in clamps now, and I've checked it to make sure that it's as accurate as I can get it. So I didn't show you the process of getting this on the floor and getting it clamped in position. It was just like Keystone Cops, really. But here it is now, and I've got 3 of the cross members in place with clamps holding those together. I just ran out of clamps, that's the problem. And at the top I've got some braces there, and I've clamped those, and I've checked to make sure that the stanchions are vertical. I've checked the diagonals on the arched members at the bottom, and I've got everything the correct measurement across these brackets here. So these should be 1100 on each one of these. So that's all good. And I've checked with a roofing square down here just to make sure I've got a right angle in here. But with the diagonals being equal, that should be right. Alright, it's getting late and I'm stinking hot and I need a beer, so I'm going to leave this till tomorrow. I've got the one spacer to put in at the other end, and I can edit out all my crappy welds again, so I've burned a couple of holes there, but I'm not going to show it. Okay, I'm off to have a beer. Well, here it is the next day, and as you can see, I've tipped the bridge over onto its side just to finish off all the welding in these cross braces. Now this is me just being expedient. I know I can do a better job with the bridge in this position. So I welded off the inside corner where the cross brace meets that arched section there, and I've done the top edge where it meets the arched section here. And there was quite a gap in that position there, so what I've done is I've filled that with a 3mm diameter piece of mild steel just to bridge that gap, and then I welded over that to close up that gap. I knew that it was going to burn a hole if I didn't do that. Now that brings me to a little conundrum that I was working my way through yesterday, and you would have heard me, sort of doing the design process in my head. Now this is where the footings are going to attach to the bottom of that post there, and remember I said that I want to be able to disconnect the bridge from its footing at a later stage if I need to do any maintenance or dismantle the bridge for some reason. And I knew that I would need to fit one of these purlin bolts through from the outside, and that would mean that I'd have to hold a nut in position on the inside while I tighten up the bolts. Now remember, this is going to be very, very close to the ground at this point, and it would have been really difficult to get your fingers up in there, especially for that top one. So I sort of put it to one side, thought about it overnight, and typically what happens is, you're having a shower in the morning and you come up with a solution. So what I'm going to do is to make a great big captive plate, or captive nuts if you like, or a plate with 2 captive nuts, that's better. So what I'll do is I'll put this piece of galvanized steel inside the tube, I'll transfer off those hole positions, and then I'm going to weld one of these nuts to the back side of that plate, and that way I can just slide that up into there, and if I dismantle the bridge, this is just going to rattle around, but it's going to be a lot easier to get that plate located than 2 individual nuts. I'm going to go over and drill this, and it's not the most accurate way of doing it, but I've got a bit of wriggle room. These bolts are 12mm, and I'll drill the hole 13 and I'll be able to maneuver that. Oh, I should have realised, I knew one of these holes wouldn't line up, so I just pulled it over with a round file, and I can assemble that. No, I can't because it's the wrong way around. And if I just center that now, tighten that down, and then I can tack these nuts onto the inside, what will be the inside of that tube. So it's sort of going to go like that. So I'm going to have to get all that primed before I put it inside, but we'll just see how it's going to work. Well, I made pretty good progress today. I've got all of the welding done, which was a real relief, and the bridge has turned out to be remarkably accurate. When I took the braces off the tops of these plates where the handrail will be mounted, it did spring a little bit, like 2 or 3 millimeters, but as far as I can tell, it's still pretty accurate. So that's a good thing. I have also been around and I've done some paint preparation on all of these welds. So I wire brushed everything, I cleaned it with a wax and grease remover, and I've sprayed on a zinc rich primer just as a temporary measure to stop any flash rust until I do a proper paint preparation on this. And the material that I'll be using is this stuff. It's a zinc gal. They call it a cold galvanized coating, but it's really just a paint with lots of zinc in it, and that will at least bond to the galvanizing, and then I can put my color coating over the top of that. I've also made up these captive nut plates, and they've been primed as well, and I'm thinking that I'm not going to weld these in place. They're just going to be pushed up inside these stanchions and bolted up. I'd imagine that I'm never going to have to remove the bridge from its footings, but just in case, these nut plates are going to be a lot easier to maneuver back in position. I could put some, like a polyurethane bonding agent between this plate and the inside of the tube, which will at least keep it from falling out. But I really don't want to weld stuff if I can avoid it, because it just burns off that zinc coating. So what I'm going to do tomorrow is get started on the handrail. When I've got the handrail bolted in place or screwed in place, I can remove these diagonal braces and do all the paint prep on these center sections here. So here we go, it's looking good. It's going to look nice with the color on it. Okay, catch you tomorrow. Well, here we are. It's finished, or at least the steel fabrication part of this is finished. And if you're wondering why you're watching this in glorious monochrome, well, there is a reason, and it will be revealed in a future episode. But I wanted to wind this video up here now because I finished all of the steel fabrication. In the next one, we're going to look at making and fitting the handrail, which is from laminated hardwood timber. We'll have a look at the bridge deck and the process for doing that. And in another episode after that, we're going to look at the site works and the insulation of the bridge. But in closing, I just want to say that, gee, it's been fun building an engineered steel bridge in your own shop. And you should too. If you're just joining me for this episode, there is a playlist, and I'll put a card up here, I think. Is that the right direction? Up there. and you can go back and check out the beginning of this project and all of the steel work that went into it up to this point. But for now, I'm going to wind this up here now and say thanks for watching, and I'll check you on the next video.